Good morning, and thank you all for joining us for a webinar today as we introduce you to the powerful capabilities of 3D Experience Delmia, a leading solution for factory simulation and engineering. Today, we are joined by Fabio, the digital manufacturing application specialist at CAD Micro. Before I hand things over to Fabio to kick us off, there are a couple of quick housekeeping items to mention. First, as usual, we'll save a few minutes at the end of today's session for a question and answer period. Feel free to type your questions into the Q&A pop-up as they come up, and we'll do our best to get to them all at the end of today's webinar. The webinar will be recorded and we'll be sending you the recording via email tomorrow. If any questions do arise afterwards, please feel free to reach out to us and we'll be in touch shortly. A little bit about CAD Micro. We were founded in 1984 and are a 100% Canadian owned and operated company. We are present coast to coast across Canada with 6 offices. Our mission is to empower clients with advanced technologies to innovate and succeed. We offer solutions across 5 oceans: design automation software, advanced manufacturing solutions, advanced simulation software, 3D metrology and scanning technology and professional services, and AR, VR, and XR. All right, without further ado, I will pass things over to Fabio to get us started.
Hello, everybody. Thank you for tuning into our webinar. My name is Fabio Colella. I'm a digital manufacturing application specialist here at CAD Micro Solutions, and today I'll be introducing and demonstrating Factory Simulation Engineer. This is a Delmia role on Dassault Systèmes' 3D Experience platform. Today we'll be introducing the solution, identifying the needs of modern production, and then showing how Factory Simulation Engineer can meet these needs. Afterwards, we'll have a demonstration of it, followed by a question period before ending the webinar. So what is Factory Simulation Engineer? Factory Simulation Engineer is a role on the 3D Experience platform that provides tools for manufacturing layout design and for factory flow simulation. Because it's leveraging the 3D Experience platform, along with it we get intelligent data management and tools that enhance our collaboration. Through this, we can utilize concurrent engineering, meaning that our production planning can happen simultaneously with our product development, reducing our overall time to begin production. As an added plus, we also get large assembly performance, which is crucial for laying out and simulating real manufacturing scenarios. So we've introduced the solution. Now let's briefly talk about the needs of modern production. As technology improves at increasing rates, all companies must grow to be competitive. We live in an experience market driven by high customization and demand by consumers. If we cannot be agile and smart in our production, we may face issues and adversity against our competitors who are. In order to work smarter and not harder, we need tools to help us do that. In modern production, we need 3D visualizations and realistic simulations so that we can effectively plan and improve our manufacturing. We also need cloud-based solutions and data management systems so that all stakeholders can remain connected, from operators all the way up to upper management. Lastly, we need tools for team collaboration so we can improve our communication and streamline our workflow. Our ultimate goal is to be tracking and managing our KPIs so that we can always be improving our processes. Digital factories are like virtual twins of a real plant, where we want the digital factory to have the tools that meet our needs. Though there are many solutions that can house virtual factories, they are not all created equal, and some won't meet all of these needs. Factory Simulation Engineer is a solution that will. Factory Simulation Engineer is a two-part solution. We have plant layout design, which allows component positioning and 2D, 3D visualization capability. It comes with a standard resource catalog for building factories, and it can also handle point cloud data of your greenfield or brownfield projects. This adds extra value when producing visualizations for all stakeholders in a project. We also get factory flow simulation, which provides discrete event simulation and has a capacity to handle complex processes and scenarios. It can handle workers, AGVs, robots, pathways, CNC machines, so that we can simulate every process that would actually happen in our plant. It would also be used to analyze statistics and to identify bottlenecks or points of improvement. And remember that these are all provided through the 3DEXPERIENCE platform. So in addition to their main capabilities, we get to manage our data smarter and work more efficiently as a team. With these tools, industrial and manufacturing engineers can create new efficient manufacturing plans, address production issues, and work on continuous improvement initiatives, all while minimizing risk and maximizing confidence that when we invest time and money into our plans, they will be successful. So they will produce better KPIs, they will improve our logistics, and they will improve our shop floor safety. We'll be creating the layout on the left side, which is a manufacturing cell that transforms the raw stock in the bottom left into the finished connecting arm on the bottom right. The raw stock has an initial machining process, an inspection, and a second machining process before being released for post-processing. We're going to complete the layout in plant layout design. We're going to complete the setup in factory flow simulation, and with that tool, we'll process the statistics and use them to determine some ways we can improve our current machining cell. Let's do it. Here I have the 3DEXPERIENCE platform opened up in my browser. Because Factory Simulation Engineer is provided through the 3DEXPERIENCE platform, we can utilize other apps and roles to improve our workflow and our collaboration. Here I have a Lean Team Player dashboard opened up, where my team can collaborate having meetings, sharing notes and documents, and tracking our progress through problems and production. We have a note on our action log telling us to start working on our continuous improvement plan. My supervisor assigned me a task on the platform through collaborative tasks. When I open my tasks, I see one in the to-do section. My supervisor wants me to complete the layout of our existing manufacturing cell that one of my colleagues partially finished. I can move the task to in work. In the task is an attachment of the manufacturing cell to complete. Because of the intelligent data system on the 3DEXPERIENCE platform, this is not a copy of the file, but a reference to the file. The platform's data system is built on single sources of truth and not worrying about file paths, duplicates, or broken links. And I can actually drag and drop this file right into my desktop app. Here we can see a cell partially laid out. We can see a couple workers, we can see some storage cells, a CNC mill, a pick and place robot, and a conveyor. On the right side of our layout, we can see a 2D sketch of our actual shop floor layout. We're going to use this to place the remaining items in their correct positions. We're going to open up our resource catalog that features a variety of different typical components that are very useful for layouts, like conveyors, storages, vehicles, and many others. Many of the resources are parametric, so they can be resized to meet your specs. We're going to use this shelf and drop it into place here. We will then modify the geometric parameters and then snap it into place. For this particular shelf, we can modify the length, width, height, the number of racks, the rack thickness. In this case, the only thing we're going to adjust is just the width of it. Now we applied our geometric parameter changes, and now we're going to try to snap it into place. Using the snapping tools in plant layout design, we can select vertices and edges on our 3D models, and we can snap them
to edges and points in our 2D layout. Using the patterning tools, we can easily create patterns of our components in our layout. Now we'll drop in some components that we have bookmarked in our platform. If we go back to our browser and go to our bookmark editor, I can see bookmarks pointing to other components that I want to drop into our cell. We can easily drag and drop these components from our browser into our desktop app. We just put our second CNC machine and our inspection table into our layout. The inspection table is already in the correct position. We're going to use the layout tools in order to move the second CNC machine into position. Now we have our completed layout. We added another CNC for the final process of production, as well as an inspection table and some storages near the exit of the cell.
Now we want to work on the factory flow simulation. We don't need to export any files or even open up a new program. All we need to do is go into our compass and select factory flow simulation, and now with the same file, we can complete all of our work. So now we've successfully switched over to factory flow simulation, and this manufacturing cell will remain the single source of truth, and we won't lose any data or interrupt any of our workflow. What we want to do now is complete the product flow from one zone to the next, ensuring we set each resource and flow accurate to real life. We'll start by adding a third worker to the new section of our cell. We can add in resource zones that will represent where our worker will go when interacting with a product zone or completing an activity.
A new worker has now been added into our manufacturing cell. We're going to drag them into the approximate zone that we want them to be working in. After we place our worker, we're now going to place resource zones. These are the dots with arrows that will be placed right next to each resource that we'll be using. This is going to tell the worker where to move to when they're interacting with products and activities at those resources. We'll set one up for the inspection table. We'll set a resource zone for the second CNC machine. And finally, we'll set up a resource zone for the shelf. Now that we've added our third worker and our resource zones, we want to start adding the product flow from each resource to the next. We're first going to add a product flow from the conveyor to the inspection table. Automatically picks up the part that we want to transfer. To the inspection table, we're going to add a generic activity. This generic activity can be renamed to inspection. Inside of this activity, we can define how long it takes to complete, and we can also set a rejection rate. In this case, we're going to leave the rejection rate at 0 for simplicity's sake, and we'll set the duration to 2 minutes. This activity will automatically detect the product that will be used in it, and within the activity, we can also assign a resource to it. We're going to assign the third worker to complete this task. We can create a new resource pool that contains the newly added worker, and now they can be assigned. From this point, we're going to add another product flow from the inspection table to the second CNC machine. Again, this will automatically pick up the product that will be used in the flow. Inside of our CNC machine, we're going to first add a load activity, followed by a transform activity, and then an unload activity. In the load activity, we select our product, our intermediary stock. Here we can set a time for loading, set it to 30 seconds, and again we can assign a resource pool, which will be our third worker. Now we can add our transform activity. This is going to describe how the machine transforms one part into another. So we first start by selecting our input, which is the intermediary stock that we're sending towards it. After that, we're going to choose our output product, which is the finished product we already have sitting in our cell. So selecting it now. You hit OK. And just like any other activities, we can define a time, we can define a rejection rate, and we can also, again, assign a resource pool. But because the machine is handling the transformation and not the worker, we won't assign a resource pool to this one. We're going to set the duration to 6 minutes. Here it lists our input product and our output product. And now we just have to add the unload activity. By adding load and unload activities, it's adding realism into our simulation, because not only is it capturing the time it takes to complete a cycle more accurately, but it's also going to be accounting for how much time worker 3 is interacting and busy actually working. So we're going to be able to tell how much they're being utilized when we run our report at the end. Now we have to complete our flow from the second CNC machine to the storage shelf. And then finally, we're going to add an out zone. This out zone is going to be the end of our simulation. So on the far left, we have an in zone, which starts our simulation, and this out zone will essentially be used for dispatching and counting all of our outputted product. Now the final thing we'll do is assign the worker to each product flow. And again, this is going to help capture how much this worker is actually being utilized, and it can also help to track things like ergonomics and logistics. If we see this worker has to walk a lot and in awkward areas, once we see that in the visualization, it's a lot easier to understand than if we have to try to imagine it ourselves. So now we've completed our flows, completed our product zones, we've added activities to all of our product zones and completed the flows necessary. One option we have between our resource zones is to automatically compute collision-free paths for our workers. And if our workers had to cross stations, automatically you can compute that path, and you can specify how much clearance they require from an object in order to pass through. And I'll show you some of these pathways made on this left side here. So you can see a collision-free path was made from the storage shelf to the secondary storage bin for that worker. So we've set up everything we needed to do for our simulation. All we need to do now is just to verify that our flow is going to be correct. So when we run our simulation, we're not going to encounter any issues. We can check the factory flow status very easily within Factory Simulation Engineer. This will give us a graphical display of varying degrees of issues or definition errors in our setup. So yellow can lead to possible errors, possible mistakes. Red would obviously be a serious error, and green is good to go. In this case, it's really just the output on our final shelf we're concerned with. It's not utilizing any activity. So we're going to add an activity there, a buffer activity, which is going to represent the quantity of final products we're going to put on the shelf before it moves to the out zone. We can double check, and that first CNC machine has it showed yellow as well, but from the configuration table, I can verify the stuff that's important to our simulation is set up correctly, so we should be good to go. Here we start with an in zone flowing to a storage shelf where the worker 1 is going to move stock into that bin. Then worker 2 is going to take stock from that bin, place it into the machine. The machine is going to machine it down into the intermediary stock and place it on the table. There we have a pick and place robot who will pick up the intermediary stock and place it on the conveyor. It'll go down to the conveyor where it is picked up by worker 3 and placed onto the inspection table. Worker 3 completes the inspection and moves it on into the second CNC machine, where after that it is moved to a storage shelf and finally moved out of the manufacturing cell. We're good to start our simulation. To start our simulation, all we have to do is hit the play button in our compass. This will automatically begin simulation in our file. As you can see, the workers start moving right away. We have worker 1 placing stock from the first shelf into the bin. The bin has a capacity of 5. Worker number 2 will work that to the machine. I can modulate the speed so we can increase the speed of our simulation. So right now it's moving very quickly, a little too quickly for us to see, but it comes out of the machine, the robot moves onto the conveyor, it gets put to the inspection table, inspection gets completed, the part gets removed from the machine to the shelf, and the part on the inspection table gets loaded into the machine. Another cool option we have here is that we can click the different resources in our factory setup, and we can watch the live state of each. So we can see their status, we can see how many items they've processed, we can see how many are in process, and we can see a variety of stats in the meantime. So every single resource and product zone that's involved in here, we can see it all. So really, really handy, especially seeing the status. Being able to see the status of each one of our resources is really useful, because as we're just watching them, we don't necessarily know what they're doing, especially the machines, for example. So we can see when they're processing, we can see when they're idle. This also helps us troubleshoot our simulation. We have some simulation options. We can enable replays, we can change our step sizes, stuff about our animation. We can define a lot of different settings that can help us get the power we're looking for. We can also open up this system performance monitor so we can track a variety of different resources utilizing different colors. to help us visualize as we're watching. But the most useful thing is going to be at the end when we can export a report in XML format. And it's very easy to read, and it can give us insightful data that we'll need. So our simulation is complete. We ran it for 8 hours, so we wanted to simulate a full shift to see what the results were at the end of that shift. We're able to quickly check the report. So in our report here, we have a variety of tables, so covering arrival and dispatch, production, storages, workers, robots, conveyors, products, operations, product inventory, and cycle times. So when we're provided with all of this information, it really helps us make informed decisions. So the process that we'd want to work with is essentially creating a simulation environment and getting results that mimic our current real-world results. And from there, we'd want to propose and implement changes in our virtual factory, run the simulation again, and essentially get the statistics and confirm that the changes we want to make will produce the improvements that we're looking for. So this solution, Factory Simulation Engineer, can really reduce the costs and decrease the time it takes to evaluate changes and to gain confidence in our solutions that we're proposing. If we look at some of the data we see in this table, just at production, so these are our machines, we can see the second CNC machine at almost 100% utilization. This right now is totally indicating to us that this could be a bottleneck or is very near to a bottleneck in our layout. And the way the cycle times were laid out, it 100% was a bottleneck in our simulation. And as the simulation went on, intermediate stock was accumulating on the conveyor belt because the first CNC machine was producing it faster than the second CNC machine could process them. And once the stock had filled the length of the conveyor, there was no more products being pulled from the first CNC machine. So 100% in that case, utilizing both the statistics and the visuals of the simulation, we could easily determine that was a bottleneck in our system. So if we look at the utilization amounts of everything else and all these other information that we're given, we can really make insightful judgments and suggestions about what we can try to do to improve. So even just looking at worker utilization, these numbers are altered because we hit a max capacity at a certain point on the conveyor belt. So there was a lot of idling. As you can see, there's a lot of seconds spent idling. So utilizing something like idle time, traveling time, and utilization amount, we could easily come to the conclusion that 2 workers weren't necessary in that one zone. And if we try to adjust and improve our machining time, or if we add a second machine, or somehow find another way to, reduce that bottleneck at the second machine, we'll be able to improve our other machine utilizations, and we'll also be able to improve our worker utilizations. And this is just the tip of the iceberg. As things get more complex and we can track more and more products and machines, we can really start to create better reports and produce more meaningful information. These reports can also be exported. And that way, they can be opened up in something like Excel, and we can add further visualizations to them to really make the most of the statistics and make conclusions from the certain data that isn't as obvious just from the table of numbers. But as you can see, there's a ton of power in this software, and the ability to work from simple to complex, and the fact that it's connected to the 3DEXPERIENCE platform is, really, really a huge benefit. With that said, we've reached the conclusion of our demonstration today. I really hope that the presentation and the demonstration were meaningful, and that I helped you understand the value and the power of Factory Simulation Engineer. Now we're going to get into a question session. So we're going to go over some of the questions that people have asked through the webinar. And now this is a good time for you to submit some questions too, if you've had any. So thank you.
Thank you, Fabio. That was a great presentation. We do have a few minutes left for questions, so keep them coming. We've got a couple in the queue already, so let's go ahead and get started. The first one we have here is, how does Delmia factory simulation handle the modeling of complex manufacturing processes such as multi-stage assembly lines or AGVs?
Thank you, Shreya. That's a great question. Factory flow simulation can handle complex manufacturing processes like multi-stage assembly lines and AGVs. It contains functions to handle assembly and disassembly activities. It can also connect multiple manufacturing cells that each have their own unique purposes. There are also built-in functions to allow automatic and manual creation of AGV pathways. Then we can further assign these pathways and add in additional logic to create the scenarios we want in our factory.
Thanks, Fabio. The next one we have here is, how easy is it to import our existing CAD models into Delmia factory simulation?
So it's a very straightforward process to add in existing CAD models to factory simulation and into plant layout. The 3DEXPERIENCE platform is CAD agnostic, so no matter the file type or the software origin of the design, we can upload CAD models to the platform, and they could be managed equally with all of our other CAD data.
Thanks, Fabio. The next question here is, can you create discrete event simulations and what-if scenarios?
Definitely. So factory simulation is based around discrete event simulation. It contains a wide range of activities and features that can model real-world scenarios. So we can add in features like decision zones that can make decisions based on current conditions. We can also add in things like failures, repairs, shift scheduling, and utilize time distributions to mimic the unpredictability of real-world production.
All right. Thank you, Fabio. That's all about time we have for today. If any questions do arise after we finish here, please do not hesitate to reply to the webinar email and we'll be in touch. Once again, thank you so much for a great presentation and thank you all for joining. We hope to see you again soon. Thank you.